Here is a second example. In this example, we're trying to find the y parameters of a transformer circuit. So here is a transformer equivalent circuit. So the problem is going to start here. I already solved a little bit, so it might save a little bit of our time in this video. So any transformer is going to have resistance of the primary winding. So here resistance of the primary winding is 2 ohms. Reactance of the primary winding is J4. Resistance of secondary is 2 ohm. Reactance of secondary is J3 ohm. Okay. So V1, I1 as usual, we'll take them as input. V2, I2 are output. Okay. I2, make sure that when you're finding Z parameters or Y parameters, we always take I2 going into the circuit. That's a important point. Okay. Now we're going to find Y11. While finding Y11 is right here, I1 over V1 when V2 equal to 0. And same way, Y21 is I2 over V1 when V2 equal to 0. So we can find by short circuiting V2, we can find these two parameters, Y11 and Y21. So what I'm going to do, I'm going to short circuit this. So V2 becomes 0. So V2 is going to be 0. Now by using the transformer ratio, we know that E2 over E1, E is the induced EMF here. So E2 over E1 equal to 2 over 1. It's a step-up transformer. So your secondary voltage E2 is twice the primary voltage. Now when it comes to the current, if it is a step-up transformer, it steps up the voltage. At the same time, it steps down the current. So I1 equal to 2I2. So current is stepping down. But at the same time, it is negative because we are choosing I2 is entering into the circuit where it's supposed to live. So that's the reason you end up having negative there. Now I'm going to find Y11. So all I need a relation between I1 and V1. So you may end up something V1 equal to something I1 plus something I1. So this is what we want, because V1 equal to that something times I1. So you can find Y11 by using this equation. So we're trying to get this equation. Now in loop 1, apply KVL. That's what I'm doing here. Apply KVL in loop 1. When you apply KVL in loop 1, V1 equal to 2 plus J4 I1 plus E1. And loop 2, apply KVL. So if you apply KVL in loop 2, E2 equal to 2 plus J3 minus I2, because I2 is entering there. Okay. So now substitute equation 1 in equation 4. So if I substitute equation 1, that equation 1 is right here. I mean, these two are the same things. So if I substitute E2 equal to E1 in equation 4, so 2E1 equal to minus 2 plus J3 I2. That's my equation 5. Now substitute equation 2, which is I1 equal to minus 2I2. I'm going to substitute that equation in equation 5 right here. So if I substitute in this equation 2, I will end up with 2E1 equal to 2 plus J3 I1 over 2. Okay. Now if I simplify a little bit, E1 equal to blah blah blah. Now that's equation 6. Now substitute equation 6 in equation 3. So equation 3, I have E1 right there. So I'm going to substitute this value, this equation 6, into here in that equation. So I'll end up with V1 equal to 2 plus J4 I1 plus half I1 plus J 3 by 4 I1. So simplify this, I will end up with V1 equal to 5 by 2 I1 plus J 19 by 4 I1. So Y11 equal to I1 over V1. So it's going to be 1 over 5 by 2 plus J 19 by 4. If I simplify, this is what I'm going to end up. Okay, Y11 equal to 1 over 2.5 plus J 4.75 Simon, that's the unit. Okay, now we can find, by using the same diagram, we can find Y21. Y21 is nothing but I2 over V1. So I already have equation 7. So equation 7, all I need to do is substitute, instead of I1, substitute I2 up. I have I1 equal to minus 2I2. So if I substitute that equation, I'll end up with Y21 right here. Okay, so I found Y11 and Y21. Now we'll find the remaining two. So to find the remaining two, it's a Y22. That's easy to find first, so I'll find that first. Y22 equal to I2 over V2 when V1 equal to 0. So Y22 equal to I2 over V2 when V1 equal to 0. So I'm short circuiting V1. Okay, at the same time, Y12 equal to I1 over V2 when V2 equal to 0. Sorry, when V1 equal to 0. So for this, I'm going to use this circuit. So that's easy to use. Okay, since the transformer is same, our transformer ratio is valid. E2 equal to 2E1 and I1 equal to minus 2I2. Those values are not going to change. Okay, so now which one? Loop 1. I'm going to take this as loop 1 here on the secondary side. So loop 1, apply KVL. Loop 1, apply KVL. If I apply KVL in there, V2 equal to 2 plus J3 I2 plus E2. That's my V2 equation. Let me label this as equation 3. I restarted the equation numbers for the second part. Okay, now loop 2, apply KVL. Excuse me. Now loop 2, apply KVL. Loop 2, apply KVL. So if I apply KVL, loop 2, E1 equal to minus 2 plus J4 I1. Why I'm taking minus? Because I1 is supposed to go in this direction, anti-clockwise, but I1 is going in clockwise. So that's the reason I end up with a negative. So that's my fourth equation. So now I need relation between V2 and I2. So what I'm going to do, I'm going to replace this equation, E1 in equation 4 with equation 1. So substitute equation 1 in equation 4. Okay, so if I substitute, that's E2 over 2 equal to minus 2 plus J4 I1. So, or I can write it as E2 equal to minus 4 plus J8 I1. I'm going to label this as equation 5. Now I'm going to replace I1 with the equation 2. So substitute equation 2 in equation 5. So I'll end up with E2 equal to minus 4 plus J8 times I1 minus 2I2. So minus minus get cancelled. I end up with E2 equal to 8 plus J16 I2. I'm going to label this as equation 6. So now substitute equation 6 in equation 3. So V2 equal to 2 plus J3 I2 plus 8 plus J16 I2. So I'll end up with 10 plus J19 I2. That's V2 equal to. So Y22 is nothing but I2 over V2, which is 1 over 10 plus J19 sine. This is Y22. Okay, now to get Y12, can I say the same thing? V2 equal to 10 plus J19 I2. Now I can substitute I2 equal to I1 over 2 minus I1 over 2. So 10 plus J19 minus I1 over 2. So I can write this as V2 equal to minus 5 plus J 9.5 I1. So Y12 equal to I1 over V2, which is minus 1 over 5 plus J 9.5 Simon. Thus this is Y12. Okay, now is your Y12 is same as Y21? So if you look at Y21, I believe it's the same thing. Okay, so this circuit is called reciprocal circuit or reciprocal network. Okay, if it is a reciprocal network, Y parameters, we can represent them with pi model. So as long as there are no dependent sources, we can represent this with a pi model. So here is the pi model equivalent circuit diagram. So here is I1, V1 here, I2 and V2 here. So this quantity is Y11 plus Y12, here Y22 plus Y12, here negative Y12. Okay, this is the pi equivalent circuit. Thank you.